The most important part of the system is something that can be seen: memory. Memory is where computers store information while programs run. Every value, status, every piece of data must exist somewhere inside the machine. Without memory, a computer could still execute instructions, but it would forget everything immediately. That means every action would vanish the moment it finished. Memory is the layer that allows the system to remember what just happened and use that information to guide what happens next. To understand memory, we need two concepts. The first is instructions. A program contains instructions that tell the CPU what actions to perform. These instructions might calculate something, update something, or check some condition. But instructions do not store information. They only describe actions. The second is storage. Storage is where the results of those actions are kept. That storage is memory. If a program calculates a new score, the score must be placed somewhere. If a system records whether a user is logged in, that information must be stored somewhere. Instructions perform work. Memory preserves the result of that work. Execution only exists while the work is happening. The moment the processor finishes an action, that action is over. The processor does not carry the result forward. Instead, the result must be written somewhere. That somewhere is memory. Think of execution like a worker performing a task. The worker performs the action, but the results must be placed on a table or stored in a container. In a computer, memory is that container. Execution performs the work. Memory keeps the result. Every meaningful action in a computer produces a result. A game updates a score. A system records whether a user is logged in. An application remembers a preference or setting, but these results cannot exist in thin air. They must be stored somewhere inside the memory. Memory is where these results live. When execution finishes, the result is written into memory so the system can access it later. If that result is not stored, the computer will forget it. The next action would behave as if the previous action never happened. Memory allows systems to preserve information across time, turning isolated actions into meaningful behavior. When we talk about memory, we are talking about state. State simply means what is currently true about a system. If a game displays a score, that score exists in memory. If a user is logged in, the login status exists in memory. If an application remembers a setting, the value is stored in memory as well. The processor does not carry this information around while it executes instructions. Instead, the processor reads and writes these values from memory whenever it needs them. This makes memory the system's source of truth. Whatever values are stored determine what the system believes is currently happening. Every new action in the system depends on what memory already contains. Imagine a program checking whether a user is logged in. The processor does not magically know the answer. Instead, it reads the stored data from memory. If memory says the user is logged in, the system behaves one way. Otherwise, it behaves differently. This pattern happens everywhere in software. The processor reads memory, performs work, and then writes new results back into memory. Those results then influence the next action. In this way, memory connects one moment of execution to the next, allowing the system to behave consistently over time. One of the most important properties of memory is that it exists across time. Execution happens in moments. A processor performs an action and moves on. But memory allows the results of past actions to influence the present and the future. When a program stores information in memory, that information can be read later. This is what allows systems to maintain continuity. Without memory, every action would start from scratch. A program would have no idea what happened one moment earlier. Memory provides the bridge between actions, allowing systems to build behavior that unfolds over time instead of resetting constantly. Another critical property of memory is that it does not automatically reset itself. When a value is stored in memory, it remains there until something actively changes it. Computers do not assume that memory should be empty or cleared. Memory holds whatever value was last written there. This behavior is extremely important because it means that all information cannot continue influencing the system long after the original action occurred. When a user signs in, the system records that fact somewhere. The processor performs the authentication process, but the result of that process must be stored. The system writes a login into memory. Later, when the system needs to decide whether the user can access certain features, the processor checks memory. If memory says the user is logged in, access is granted, otherwise denied. Again, the processor performs work. Memory stores the result. Consider a game scoreboard. When a player earns points, the processor performs the calculation. But once the calculation finishes, the result must be stored somewhere so the system can display it. That number is placed into memory. Eventually, long-term storage. The next time the game needs to display the score, the processor reads the value from memory and shows it on the screen. If the score increases again, the processor reads the current value from memory, updates it, and writes a new value back into memory. The scoreboard works because memory preserves the score between actions. Applications rely heavily on memory to store settings. When you change the setting, the processor performs the work needed to update the system, but the chosen value must be stored somewhere. So the application will remember it in the future. That value is written into memory. The next time the application needs to check, it reads the stored preferences from memory. Whether the settings control display, notifications, interface layout, the system relies on memory to remember the user's choice. Where does state live? Where inside the system is information stored? Who can change it? Which parts of the system are allowed to modify stored information? How long should memory exist? Should the information disappear quickly or remain for a long time? These questions help developers understand how systems behave and how they evolve over time. Even without knowing any programming syntax, these questions provide a powerful way to analyze how software works. Instructions describe what actions are possible. Memory determines what actually happens when those actions occur. The same instruction can produce different results depending on what values exist in memory. The stored state inside memory influences what happens next. The cycle repeats continuously while software runs. The processor reads memory, performs actions, and writes new results back into memory. Those results become the new state of the system. Memory is a layer that connects every action together, turning isolated instructions into systems that evolve and respond over time.